everybody, in this video we're going to go through the review sheet for test number 1. So in the first question we are told that we have a right triangle because we're told that we have a 90-degree angle. This leg over here is 5 radical 2 and the hypotenuse is 2 radical 15. We need to find the missing side of the right triangle. Whenever we have two sides of a right triangle and we need to find the missing side length, we can use the Pythagorean theorem in order to do that. So remember, for the Pythagorean theorem, A and B are the legs. So one of the legs is 5 radical 2, and remember your parentheses when you plug in. We don't know what the other leg is, we're solving for it, and the hypotenuse is 2 radical 15. So when you put 5 radical 2 squared into your calculator, that should give you 50. And when you type in 2 radical 15 squared into your calculator, that should give you 60. Subtracting 50 on both sides, we have b squared is equal to 10. Taking the square root of both sides, we have our answer. The missing leg is radical 10. Moving on to the next question, and sorry about the background noise. I'm in the school building and there's a lot of background noise outside of the school. So this is the construction of an angle bisector. So the angle bisector means it's being split equally into two congruent parts. So answer choice 2 is the correct answer because it correctly says that this half, ABD, is equal to this half, CBD. A lot of people pick 4 without closely reading the question. So CBD is not 1/2 of ABD. ABD would be 1/2 of the whole ABC, but there isn't an answer choice that says that the half is half of the whole. So just make sure you go through the answer choices carefully and you make sure it's actually saying what you want it to say. In the next one, we're naming an angle that is supplementary to angle AOB. Supplementary means two angles that make 180 degrees together, and that means that they form a straight angle, which is a straight line. So angle AOB is this 90-degree angle right here. So the answer choice that would make a straight line with it is this other 90-degree angle over here, because 90 plus 90 makes the full 180-degree straight angle. If you put it together with the other angles in the answer choices, it will either be less than 180 or greater than 180, but it'll only be exactly 180 degrees if you put another 90-degree angle with the 90-degree angle that we already have there. Here we have two complementary angles, and that means they add to 90 degrees. The angles are in a ratio of 3 to 6. When you have a ratio, you can represent the 3 part as 3x, and you can represent the 6 part as 6x. And when we add them together, since they're complementary, we know that they should make 90 degrees. So here we have 9x is equal to 90, so x is equal to 10. And then if we plug in, 3 times 10 is 30 degrees. 6 times 10 is 60 degrees, because I just subbed back in for both of the angles. So the larger of the two angles would be 60 degrees. Okay, for the next one, there's lots of different possibilities. Just make sure you're using the correct notation. I'm going to name ray OD, and I'm going to name ray OA. I'm going to name line segment AO and line segment OD. And I'm going to name line AO and line OD. Just remember your notation. And I'll just name the 90-degree angle, angle BOA, using my angle notation and my 3 letters with the vertex of the angle in the middle of the 3 letters. Okay, I'm not going to graph number 6. You can graph it on your own paper so you can see the quadrilateral. I'm just going to go through the calculations. So the midpoint of AC, we need to be using midpoint formula, which you do need to know for the test. Midpoint formula is the average of the x coordinates, comma, the average of the y coordinates. The x coordinates are -2 and 9. And the y coordinates for AC are 2 and 4. And that's 7 over 2, which is 3.5, and 6 over 2, which is 3. BD we're going to be using points B and D. So the x coordinates are 1 and 6. And the y coordinates are -2 and 9. So that would be 7/2, which is once again 3.5. And 7/2, which is 3.5. Okay. Then we're going to be using the distance formula to find the length. Anytime you need to find the length of a line segment, that is distance formula. You do need to know the distance formula for the test. So make sure that you do come in knowing that if you would like to use it. Okay, AC, the x coordinates are 9 and -2. Okay, and the y coordinates for A and C are 4 and 2. So that is 11 squared, which is 121, plus 2 squared, which is 4. So that is radical 126. Oh, sorry, 125. I can't add today. Radical 125. Please leave as a radical. Do not round unless the question specifically asks you to round. Let me just double check that. That was 4 minus 2, AC, yes, 4 minus 2, 2 squared is 4. Okay, I'm always making mistakes in my calculations. So if you find an error, please let me know. Okay, BD. So the x coordinates are 6 and 1. And the y coordinates of BD are 9 and -2. Okay, so that is 5 squared, which is 25, and 11 squared, which is 121, and 121 plus 25 is 146. So the conclusion that you were asked to draw here is ABCD a rectangle? And you're told that rectangles have congruent diagonals. The diagonals here are not congruent. So your conclusion would be no, not a rectangle because the diagonals are not congruent to each other. Okay, moving along, we're told that we have a bisector of the angle. So the angle is split into 2 equal parts. So we can make an equation that says 1/2 is equal to the other half. Subtract 6x on both sides. Add 6 on both sides. Divide by 2. And then we do need to plug in to find the measurement of the angle that it's asking for, which is LJM. So it's asking for the whole entire angle. So 6 times 4 is 26. So that means this is also 26 because they're equal. 26 plus 26 is 52, if I am adding correctly in my head right now. Okay, for this next question, you needed to find the error that the student made. So the error in the first one was they don't have a radical, so the radical does need to follow all the way down. It is part of the distance formula. And in the second one, what the student did is instead of doing x2 minus x1, they did x2 minus y1. So this set of parentheses should be x coordinates. So here we have an x coordinates. And this set of parentheses should be y coordinates. So the y coordinates are the ones that are second in the parentheses. Okay, moving forward, you can find the point that's 1/4 of the distance, or the point that splits your line segment into 4 equal parts, by first finding the midpoint of the line segment that will split it into 2 equal parts. And then if you take the midpoint of each of those halves, that will split into the 4 equal parts that you need. So if we're doing this with constructions, what we need to do is we first need to find the midpoint. And then once we get the 2 halves, we'll find the midpoint of each of the halves. So the perpendicular bisector construction is the construction that allows you to get the midpoint. So I'm going to go over to one endpoint, And it doesn't matter the distance or the hole that you use on your compass, just more than halfway down. An arc above and below, and then without changing your hole or your distance, so using the same hole or the same distance, go over to the other endpoint and just make the same exact arc using the same exact hole. And what we're going to do is we're going to make the perpendicular bisector right through those intersection points. Oops, my bad. And that point is the midpoint of the line segment. So now we have the two equal parts. So what we're going to do now is we're going to go to each of the halves and we're going to split that in half. So here's one of the endpoints. It's only up to here. So I want more than halfway, but not off the line segment. Okay, arc above and below. And that half ends here at the midpoint. So using the same distance, I'm just going to make the same arc. Oops. Oh no, mine moved, but at least I had finished making it before my distance changed. I hate doing constructions on the computer. It's really, really annoying. Okay, so we split that half in half. And then we just need to split the other half in half. So I'm just going to come over here. Oops, I keep clicking all the wrong buttons also. Okay, more than halfway down and arc above and below. And then without changing my distance or the hole that I'm using, I'm going to come over here. Oops, and I'm going to make the same exact arc using the same hole or the same distance. Oh no. I wanted to get rid of my compass. That's the button to click. Okay, from here, make my perpendicular bisector right through those intersection points. And there we have it. We have the halves of the halves. So what we have is now 1, 2, 3, 4 congruent pieces. So we are all good to go. Okay, for the next question, oops, we are given the coordinates of the midpoint of the line segment, and we actually need to find one of the endpoints. So it's kind of backwards from what we're used to seeing, because usually we're given the endpoints and we're told, use the midpoint formula and find the midpoint, but here it's a little bit different. So 1, 2, 1, 2, 3, 4. So that is the midpoint of the line segment. So I'm going to label that M for midpoint. Point B is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And we have to find the other endpoint A. Remember, the midpoint is exactly in the middle of the line segment, so it's equidistant from both endpoints. So to get from the midpoint to this endpoint, it's over 1 and up 1, 2, 3. So to get the other endpoint, I'm just going to do the reverse. Over 1 and down 1, 2, 3. And there we have it, the coordinates of point A, which is 1, 1. You could also use the midpoint formula, which is the average of the x coordinates and the average of the y coordinates. We do have one of the endpoints, so we do know one of the x values. We don't know the second one. And we do know the x coordinate of the midpoint, so the average of the x coordinates is 2. So if we multiply both sides by 2 to solve the equation and subtract 3, we do get the x coordinate of 1 for the other endpoint. And for the y coordinates, we do know that the y coordinate of the endpoint B is 7. We don't know the other y coordinate of the other endpoint because we didn't have it to begin with. And we do know the average of the y coordinates is 4 because that's the y coordinate of the midpoint. Multiply by 2 on both sides. Subtract 7. And there we get the same thing, 1, 1, which we found over here. But I prefer to do it graphically. I think it's just easier. Just count the spaces from the midpoint to the endpoint and just do the reverse to get from the midpoint to the other endpoint. And there you go. That's all it is. Okay. For this next one over here, it really should say that B is in between A and C, so that way you could draw a picture. So here's A, B is somewhere in between, and here's C. And we know that AB is 2x, and we know that BC is x plus 6, and we know that the whole thing AC is 24. So using the partition postulate, we can make an equation that says if we add the parts together, we get the whole. So that's 3x plus 6 is equal to 24. That's 3x is equal to 18. So we have x is equal to 6. So here, AB would be 12. BC would also be 12, and that would make 24. So here, B actually did turn out to be the midpoint. because we had equal parts on both sides. For question number 11, we needed to draw a line segment and then copy it somewhere else on our paper. So I'm just going to draw a line segment, and let me get my compass out. So in order to copy a line segment, let me just move this down to give me some more space. Oops. Okay, so to copy a line segment, we have to measure it. Once again, let me just move this down to give me more space. There we go. And I need a starting point for where I'm going to move it to. So I'm just going to move it right over here because I have space over here next to it. So that's going to be where I'm going to move it to. So I'm going to put my compass on one of the endpoints. And since I want to measure it, I want to get the measurement of the whole thing. So I'm going to line it up with my hole or my distance. And I'm going to just make an arc to show I measured. If you don't make an arc to show that you measured, then nobody who's looking at your test knows that you measured it. And that's important because they have to know that you used a compass in order to do it. Okay, so I just took that measurement, and I probably should have done this first before I measured that, but oops. Okay, so I probably should have done this first before I measured it. Sorry, I'm clicking all these things on the computer. Very hard to do constructions on the computer. I'm just going to make a line segment here that's obviously longer than the one that we have here, so I give myself plenty of space. Now I measured this, I lined it up. Oops. Okay, I measured this. So I'm going to take the measurement over here where I'm moving it to. And there is where my new line segment ends. So from here to here is congruent to the original one. And we can leave this to show that, we measured it. You're really not supposed to erase when you're doing constructions. But the reason why we made it a little bit longer at the beginning is because so that way we can come short when we were transferring the measurement from here to here, because that would have been a little bit of an issue. Now we need to double it. So I'm just going to keep what I measured. If you lost your measurement, you could just go back and remeasure the original line segment. And I don't have so much space here, so I'm not going to do the tripling. The tripling would be the same thing as doubling. You just do it again another time. So I'm just going to take the distance, go over here, and do it again. And this whole line segment from here to here would now be double the distance of the original one. It would be double the length because all we did is we took the measurement and we did it again. So we doubled the distance. And you can triple it if you have more space on your paper by just taking the same measurement and putting it here. I don't have room for that because I started mine too far to the right. Okay, so here we're going to practice copying an angle and bisecting an angle. So you really should use a straight edge to make angles. But I'm on the computer, so this is very, very difficult. So here I have an angle, and I'm just going to call this angle A. So I'm going to copy it right over here, and I'm just going to call this A prime, and that means just I took point A and I moved it somewhere else. I'm going to make a ray here because angles are formed by rays, and that's going to be my starting point. Let me get my compass. I don't know where it went. There it is. Let me bring it down. So to copy an angle, you're going to start on the vertex of the angle that you're copying. And it doesn't matter the distance of the hole, and you're just going to make it mark. This one, distance does not matter. But whatever we do there, we're just going to do here because we are going to be copying it somewhere else. Here we go. Now, when we actually have to measure with our compass. So where the arc hit the angle, that's the measurement of the angle. So that's what we're going to measure. So I'm going to take my compass, and what I want to do is I just want to measure from one of those endpoints to the other endpoint. And I'm just going to put a little arc to show I measured. I'm just using another color so you can see it. And since that's my measurement, I don't want to lose the hole or the distance. And I'm going to pick my compass up, and I'm going to go right over here where that first arc hit the angle. And I'm just going to swing up. Oh no, I wanted it to intersect, but I didn't make this first arc long enough. If you run into that issue, that is totally fine. All you have to do is go back and find the measurement that you had it open to. So you found it. And then I can go back over here and I can just extend it until I see that intersection point. But that's why it's better to make your arcs longer at the beginning. But I did want to show you, like, it's okay if you don't see the intersection, you can just go back and extend as long as you find the whole distance that you were using. And then right through that intersection is where you're going to make your second ray. And now we have our angle, and our angle is exactly congruent to the original one. Okay, now we're going to bisect this angle. So let me use a different color. So I'm going to use yellow for this construction, so that way you can tell the difference between the arcs. So the bisect, we're going to go on the vertex, and we're just going to make any random arc. It doesn't matter. What is going to matter is where we put the compass next. So where your arc hit the angle, and that's where we're going to have to put the compass next. So I'm going to put my compass on that top one. I'm just going to open up a little bit wider. I'm going to use yellow again. I know it's a little hard to see. I'm just going to go up and down. And then using the same measurements, since I'm bisecting or cutting in half, I'm going to go over to that other intersection point and just do the same thing. Oops, without changing the distance. Good thing I made that already. Okay, now from the vertex through that intersection, here's my bisector, and it splits the angle into two equal parts. This half over here is equal to this half over here. And it should look like it's equal, otherwise probably you did something wrong. And those are all the constructions that you're responsible for knowing. Copying an angle, bisecting an angle, and the perpendicular bisector that we did in the question number 8, the second number 8. And remember to also know your distance formula and your midpoint formula, because those are not going to be provided to you.